Hello, people, and welcome back to this session on problem solving on simple linear regression and multiple linear regression. We have already covered the theoretical aspect of both simple linear regression and multiple linear regression. Therefore, in this session, we are going to be solving a few problems. So, like the last time, we solved problems on basic hypothesis testing on z-test and t-test. The methodology that we followed was that I told you that you can pause the video, solve the question by yourself, and then match your answer. If your answer is matching, well and good. Else, I'm going to anyway solve the problem. So the recommendation goes exactly the same for this particular session as well. We'll be solving a few questions on both simple linear regression and multiple linear regression. So my request to you all will be that the solutions are actually given. I mean, when I say solutions, I mean the final answer of the question is already given. So you can try and solve the question by yourself. Find out if you're getting the exact answer. All of these concepts have been covered extensively in theory. And if you get the right answer, well and good. Else, you can look at the solution and you can figure out where you went wrong. Okay, with that said, let us go ahead and start with the first question. The first question says, a least square simple linear regression model was fit predicting duration in minutes of a dive from depth of the dive in meters from a sample of 12 penguins diving depths and times. Calculate the F statistic for the regression by filling in the ANOVA table. So what they're calculating here, they're trying to predict the duration of a dive from the depth of a dive. So if my linear regression equation, or rather I should say simple linear regression equation is like this: y is equal to beta naught plus beta 1x. Here, y is the duration of dive, and x is nothing but my depth of the dive. Based on this equation, or rather I should say, based on the data available from a sample of 12 penguins, they have calculated the ANOVA table for this simple linear regression problem/model. Now, they have given you a couple of values. They have given you the mean square value, they have given you the total sum of square value, and you're expected to calculate the F statistic. Okay. Basically, you need to fill this table and you need to find the incomplete values from the values which are already given. So let's go ahead and get started. What all you have been given? You have been given total sum of squares. You have been given residual mean square. You can also calculate your degrees of freedom because you have been given the sample size. Also, for a simple linear regression equation or for a simple linear regression model, your value of k is equal to 1. From this, you can calculate regression degree of freedom, nothing but equal to k, which is equal to 1, and residual degree of freedom nothing but equal to n minus k minus 1, 12 minus 2, 10. Now you have been given the mean square of residual. You know residual mean square is equal to residual sum of squares divided by residual degree of freedom. What is residual sum of squares? That is something that you need to find out. You have been given this value is equal to 2. What is my residual degree of freedom? Nothing but equal to 10. So my residual sum of squares has become 20. Okay, now we know that total sum of squares is nothing but residual sum of squares plus regression sum of squares. From here, I can directly subtract these two entities and I can get my regression sum of squares as 10. Okay, now I need to calculate my regression mean square. This is the equation. What is regression sum of squares? 10. What is my regression df? 1. Nothing but equal to 10. Now we have regression mean square as 10. Residual mean square as 2. My F statistic is equal to regression mean square upon residual mean square, which is nothing but equal to 10 by 2 is equal to 5. So your final answer to this problem is 5. This was your first problem. Now we'll move on to the second problem. I'll, I'll keep all these values because this we will also need in the second question, because as you can see in the second question, the table is the same. Now, if you read the question is exactly the same as the previous one. What we need to calculate that has changed. We need to calculate R squared value for the regression from the ANOVA table. Okay. So how do we calculate R squared in case of a simple linear regression or in general for linear regression? How do we calculate R squared? If you remember, the value of R squared is given by sum of squares of regression divided by total sum of squares. In case of simple linear regression, this is also equal to the square of the correlation coefficient. But since we have insufficient data to calculate our correlation coefficient, we will be directly using this formula to calculate my R squared or my coefficient of determination. If you replace the values, your regression sum of square is 10, total sum of square is 30. That gives you 1 by 3, which is somewhere close to 33%. Okay, this is your answer. So if you do the calculation, this will come out with 33.3333, which we can round it off to 33%. So this was question number 2. Let us move on to the third question. Third question says, the shear strength of the bond between two types of propellant is important in the manufacturing of a rocket motor. An investigator is interested in whether the age of the propellant is related to the shear strength. Data from 20 paired observations were used to fit a least square simple linear regression model predicting shear strength from propellant age. So shear strength is going to be my dependent variable, and that is dependent on the propellant age. Propellant age is the independent variable, and this model is a simple linear regression model. They have already given the equation. The equation of the regression is given by y predicted is equal to 1000 minus 38 into independent variable x. Use this equation to predict the shear strength when the propellant is 20 weeks old. Here my age is in weeks and my data is also given in weeks. So we have to calculate my shear strength, which is nothing but y cap. I can directly put value 20 in the equation to get my answer. So this is nothing but equal to 1000 minus 38 into 20, which is equal to 1000 minus. So 240 is going to be the answer to this question. Basically, it was just putting the value of x in the equation to get the value of y. Very simple. Let's move on to the next question. Calculate the correlation coefficient for the following data. So for this data, you need to calculate your correlation coefficient. How will you do this? So basically, you have been given a few points. Let us suppose this is 1, 1, 2, 2, 2, 3, 3, 2, and 4, 4. These are the set of points that have been given to you. For these set of points, you need to calculate the value of correlation coefficient. So you can use R programming here. You can go to R. You can basically use the core function in R as we studied to calculate the correlation coefficient between your two variables x and y. So what is my x over here? X takes the values 1, 2, 2, 3, 4. Y takes the values 1, 2, 3 to 4. This is coming out to be 0.8076923. So we can round it off to two decimal places. And the final answer that we'll get is 0.81, okay, which is my answer. Now here the next question says, a least square simple linear regression model was fit predicting y from x. See the output below. What is the equation of the least square regression line? You have been given the summary table of a least square simple linear regression model. From that, you need to derive the equation of the line. So we know that my equation of line for a simple linear regression model is y is equal to beta naught plus beta 1 into x. So I just need beta naught and beta 1 to create the equation of my line. I have been given the estimate of the intercept and the estimate of the slope. What is the estimate of the intercept? Minus 45. What is the estimate of the slope? 3. This is the equation of my line. As simple as that. Let me remove this and then we'll go ahead to the next question. This is an interesting question. This question says, in the figure below, the association between x and y is shown in a scattered plot with the least square linear regression line. Which of the following assumptions of regression would you be most concerned about violating if you were the analyst working with this data from review of the scatter plot below? So it's asking me which model assumption is this particular scatter plot violating. Remember, there are four model assumptions that we studied. And what were the four model assumptions? Linearity, independence, constant variance, and normality of residuals. These are the four model assumptions. So we will see the residual plot of this particular scatter plot and see which of the four assumptions is it violating. Now, if you turn this line into a horizontal line, then you will see that the points are fairly randomly scattered and you are not able to see that a non-linear pattern. There is no non-linear pattern that exists in this particular scatter plot. So we can surmise that linearity assumption is met. There is nothing spoken about the way in which x and y have been collected. So by default, we need to make that assumption that x and y have been collected independently. When it comes to the variance, you can see that the variance of this particular scatter plot, the variation of points in the residual curve or in the residual plot of this corresponding scatter plot is reducing as the plot is going ahead, as the line is moving forward. So there is more variance over here and there is less variance over here. So the variance is not constant throughout. It has changed from one position to the other position. So we can say that the assumption of constant variance is not met. So your answer would be you will be most concerned about the assumption of constant variance, since this scatter plot is violating the assumption of constant variance. We'll move on to the next question. Question says, the association between resting heart rate and diastolic blood pressure was investigated. A least squares regression line was fit, which gave the following equation, which is y is equal to 1.2x minus 20. One subject had a resting heart rate of 70 and their diastolic blood pressure was 60. So, the association is between resting heart rate, which is the independent variable, and the blood pressure, which is the dependent variable. So it's saying for a particular patient, your resting heart rate was 70. Xi was 70 and Yi, which is the original value or the actual value of the diastolic blood pressure was 60. Now calculate the residual associated with this subject. What do you mean by residual? Residual means the difference between the actual value of the dependent variable and the predicted value which is given by the model. So from a mathematical perspective, residual is equal to yi minus yi cap. So yi cap is equal to 1.2 into 70 minus 20, which is 64. This is equal to 60 minus 64. You get minus 4. This is how you calculate the residual. Now the next question says a summary of the output from the least square regression model is shown below. What is the value of k for this regression? Now, how will you write the equation of the MLR line for this particular summary table? Well, it will be y is equal to intercept plus 0.06 times age plus 0.15 times weight minus 0.08 times temperature. It is asking me the value for k. Now the value for k in case of a regression context is nothing but equal to the number of independent variables. So how many independent variables are here? There are 3 independent variables, age, weight, and temperature. So the value of k is nothing but equal to 3. Next question, a least square multiple linear regression model was fit on 49 observations. The resulting regression equation is given by y cap is equal to 75 plus 3x1 plus 5x2 minus 3x3. Calculate the F statistic for the regression by filling the ANOVA table. Similar question that we did above, but the context has changed from simple linear regression to multiple linear regression. So let's do this. You have been given residual sum of squares. (180). Total sum of squares 200. What is regression sum of squares? Total sum of squares minus residual sum of squares, which is 20. To calculate degree of freedom, again, your regression degree of freedom is going to be equal to k, and which is nothing but equal to, here you have three independent variables, x1, x2, and x3. This is nothing but equal to n minus k minus 1, n minus 4. Here your number of observations are 49, so 49 minus 4 gives me 45. All right. So how do you calculate F statistic? You calculate F statistic using regression MS upon residual MS, which can also be written as, regression SS upon regression DF upon residual SS upon residual DF. Now, what is regression sum of squares? Calculated value 20 by 3 upon 180 divided by 45. Upon 45 by 180. So you get 9 here. This 5. So this comes out to be 5 upon 3, which is equal to, if you do the math, 1.6667. This is my answer. Yep, around 1.67. This is my answer. So these were some of the sample problems on simple linear regression and multiple linear regression. Thank you so much for watching. I'll see all of you in the next session. Thank you.